So when trying to solve these, when you're trying to solve these types of problems, there are a few different things that you're going to see. When I look at this sheet, I see 3 distinct types of problems, and that's hopefully my goal is for you to understand those 3 types. Okay? The first type and the easiest is when I look at them, I just kind of count how many times x appears. So like in this problem, x appears 3 times. Here it appears multiple times. Here it appears multiple times. Here it only appears once. Once. T is like x. Once. Multiple times. Multiple times. Multiple times. Multiple times. Once. Multiple times. So it either appears once or it appears multiple times. That's what I see as someone that understands how to do these. So the first thing I do when I'm solving for x is I count how many times x appears. And really, I guess I really don't care how many times it appears. I just care, does it appear once or does it appear multiple times? If it appears once, that's a very easy way to solve it. So you have 2 things from there. It could appear once. If our answer is it appears once. Okay? For instance, if I had a problem, say like number 5 off yesterday's assignment, 3x squared minus 2. So an example would be y equals 3x squared minus 2. X appears 1 time. Okay? We solve it using inverse operations. Now most of you have heard that phrase before, or that used before, use inverse operations. Hopefully most of you know what it means, but that just means you do the opposites. You solve it like a normal equation. Okay? Remember the x-intercept, which is what we're looking for, is when y is 0. So 0 gets, we make y 0. And then we just do opposites. We add 2, divide by 3, and take the root. It's that simple. Okay? So from here, 3x squared equals 2. X squared equals 2/3. X equals plus minus root 2/3. Now I'm not going to worry about rationalizing that and calling it 3 root 2 over 3 or anything like that. Because the reality is, if I'm finding zeros here, I most likely would end up rounding that answer at the end, because I would want to know where it's crossing the x-axis. And in fact, this time it would be plus minus 0.8 if you rounded it. That would be approximate. That is how you solve them when x appears once. Now when you're looking at your paper from yesterday, notice how many of these problems where x appears once. 1, 2, 3, 4, 5, 6 times, right? 6 out of the 14, x appears once. Now, does that mean you have all those done? It doesn't necessarily mean it. Maybe you're confused and you don't get it. But that's our goal right here, is to make sure you understand what to do. So when you're looking at these now, when x appears once, you should be going, that's an easy problem. I just do inverses. If x appears multiple times, so I guess before we move on from there, any questions on that? Yeah?
Oh, so when x appears once, and if it's like number 11, or it's like t to the 5th, would
Yep.
it just be like 5 root and then whatever?
So the 3 steps, there's 3 steps on number 11. You subtract 2, divide by -4, and take the 5th root.
Okay.
And when you do an odd root, remember it's not plus minus. Right? Only even roots are plus minus. Odds are not. Okay? Everyone get that? Okay. Next, when x appears multiple times. So you have multiple x's. An example, there are a couple examples of this. You could have a problem that looks like, say, the 3 hardest problems on here are 1, 2, and 4. So I'm skipping over those for now. Let's pick up like number 13. Number 13, y equals negative 2 x to the 5th plus x cubed. So x appears multiple times, but in this problem, there's only x's, right? Each term has an x. So you could have a problem that looks like this, and I'm purposely skipping a lot of room because I'm going to list two different examples here. Or you could have a problem, say, that looks like number 20, y equals x squared plus x minus 6. Now notice in this problem, you have x in both terms. Here you have x, and you have a negative 6. You have a constant. So when it appears multiple times, you could have x's in every term, and you can have x's with a constant. You solve those in two different ways. You have done a lot of solving of these. More than you want to do, probably. Okay, how do you solve this quadratic? Nick?
You factor it?
Yeah. In this case, you factor. Or, if factoring doesn't work, or you don't want to do that, you could use quadratic formula. Or you could complete the square. Or graph, calculator, any of those things you could do here. Notice you're doing that, though, because there's a constant there. That is what I recognize. So, like, once again, being the person who's experienced a lot of math in here, I'm looking at this and I go, this I solve much differently than I solve this one. Because this one has a constant without an x. This does not have an x. Or, excuse me, each of these have an x. This one does not have an x. This is the reason. Now, if that 6 wasn't there, I would solve both of these the same way. I'd start them at least both the same way. But since the 6 is there, it messes it up. Now, you guys know how to factor. I would expect everyone could look at this and go, well, two things that multiply to make negative 6 and add to 1 are 3 and negative 2. Remember, when you're solving, you're saying that equals 0. So if x plus 3 equals 0, that tells me that one of my answers is x equals negative 3. And if x minus 2 equals 0, that tells me one of my answers is 2. Those are my two solutions, 2 and negative 3. You did all that last chapter. That's when you have multiple x's, but you have that constant as well. When you don't have that constant, say like this one up here, that makes it easy. What's your greatest common factor?
X to the third.
X to the third. When we set that equal to 0, we look at this, and when each term has an x, you just look for the lowest degree of x. In this case, it's x to the third. I think you just set it over there somewhere. Thanks. Okay, so we're going to pull out that x to the third. X to the third times what is negative 2x to the fifth?
Negative 2x squared.
Yeah, negative 2x squared. And x to the third times what is x to the third? 1. And that's key to put that 1 there. Okay, so now those two things multiply together to make 0. That means this would have to be set equal to 0. And this would have to be set equal to 0. If this equals 0, x is 0. Because you take the cubed root of 0, and that's 0. Set this equal to 0, subtract 1. Divide by negative 2. Take the root. Once again, I probably wouldn't worry about rationalizing it, because in this case, I'm really just looking for where that crosses the x-axis, what makes that 0. The answer is, like, if you change it, it's plus minus 0.7, I think is the approximation there. Okay?
0.
And the 0, yep. Right, so now we've hit on all three different types when we have x appear once, x appears twice, or multiple times, okay? Without a constant, with a constant. Notice when it appears here, when we factor it, we get back to this piece where x only appears once. So we really jump back to this route. Right? That's why we start out with the easy, move to the more difficult, which incorporates the easy. And then here we have the factoring. You have some special cases where you take this on, but you end up with other pieces here. So are there questions with this? Yeah.
How did you get +1 again?
Where at?
One in the middle.
I took out x to the third. X to the third times 1 is x to the third. That's the 1. Other questions? Okay, let's take a look at a problem like number 16. The two others we'll do a quick look at. 16. So when you're looking at 16, y equals 2x cubed minus 3x squared plus x. Does x appear only once? Answer is obviously no. Okay, x appears multiple times. Do we have a constant? Or in other words, does x appear in every term?
Yes.
Yeah, it does. So that means, that would imply I factor out x. When I take x out, that leaves me with x times 2x cubed, or excuse me, x times what is 2x cubed?
2x squared.
2x squared. X times what is negative 3x squared?
3x.
Or x. Negative 3x.
Negative 3x.
Negative 3x. And x times what is x?
1.
1. Make sure we have the 1. And from there, this times this equals 0. That means you have to set each of them equal to 0. X equals 0. And 2x squared minus 3x plus 1 equals 0. This one's easy. That's the answer. This one's not as easy. What do you do with this?
Subtract 1 from each side.
Okay, so let me point something out real quick. You're now back to this place. Okay, when we look back at our previous page of notes, we're asking again. We start back to where we were. We have a new problem. Does x appear once? No. Does it appear multiple times?
Yes.
Yes. Is there a constant?
Yes.
Yes. What do? Yeah. You factor, or use the quadratic formula, or complete the square, or graph, or use your calculator. Use one of those methods. Okay? So I'm here. I'm going to try to factor. Two things that multiply to make 2, a times c, and add to negative 3. Well,
Negative 2 or negative 1.
negative 2 and negative 1. Don't forget to divide by,
2.
yeah, divide by your a term. Okay, that makes this part become negative 1. This part is negative 1/2. Okay, when we factor it, we get x minus 1 and 2x minus 1. Set that equal to 0. X minus 1 equals 0. X equals 1. Set that equal to 0. 2x minus 1 equals 0. 2x equals 1. X equals 1/2. 3 answers. 1, 2, 3. It's a cubic, so you could get up to 3 answers. So once again, it makes it, you guys, if you can try to think about it in this process where you're counting and you're applying what we've done in the past, really this is a culmination of a bunch of work you've done trying to put it all together now. And it's not always easy to take and look at a sheet and go, well, I got to apply a bunch of different skills all on one sheet. You've got to really organize yourself. That's what this is for. Okay? How many are with me now? All right. So there are 3 special case problems on here that we one of which we talked about yesterday. This right here, anytime you have a power that's not a quadratic, and you look and say there's multiple x's, but you have a constant out here, for instance, this problem, number 2. What other ones like that? Number 1, you have multiple x's and you have a constant. Okay? So here you have multiple x's and a constant, multiple x's and a constant. This one you actually have multiple x's and a constant as well, and it's not a squared. We talked about how to solve these yesterday. You could actually on this one do factor by grouping, but if you don't feel comfortable with that, if you're struggling just on the other stuff, use your calculator and calculate your zeros. If you don't recall how to do that, look back to yesterday's lesson. Look online. I walked you guys through it. I do that both for this one and this one if I'm struggling. If you're not struggling, then challenge yourself to use factor by grouping on this one. It can be grouped and you can factor. This one right here, you should look at and go, whoa, that's a 4th power. So as long as this is half, if that power is half of that, you can work on factoring that. And we talked a bit about that yesterday where we said we can write that as x squared minus 13x squared to the first plus 36. And now if you kind of ignore what's in there and just think, well, I have a quadratic. My coefficient out here is 1. So really I'm saying what 2 things multiply to make 36 and add to negative 13?
9 and 4.
Good.
-4.
Negative 9, negative 4. So that part's really the same. The only thing that's different is usually we put what is being squared in front. Well, usually it's an x squared, right? Like if we were doing number 20, there's an x squared there. Well, the thing being squared isn't x, it's actually x to the 2nd power. And so that goes out in front. And from there, you set that equal to 0. X squared minus 9 equals 0. So x equals plus minus 3. You add 9, take the root. X squared minus 4 equals 0. Once again, you add 4 and then take the root. And when you impose an even root, it's plus minus. Those are your 4 answers. It's a 4th degree. You could potentially have 4 answers. Okay? Okay, how many are with me now? How many feel better about it? Okay, so your goal tonight, like number 1 is to get this finished because this is on your quiz tomorrow. Number 2 is to do what we're going to do today because that is due after Christmas. That does not mean you should wait till January 3rd to do it. Otherwise, you're going to be struggling. And by the way, if you are at home and you don't remember how to do this stuff, what should be your the first thing you do? Jody?
Go on the video.
You go online. That's why I record this stuff. This is recording right now. So you could say hi to yourself and you could watch it. Yeah. See?
Hi, Nick.
Cody, you're the best.
Hello.
So you guys really should watch this. I don't record it because I like watching them. Okay? I do, though. I mean, it's kind of fun. Family movie night. All right. Don't mess up the microphone, please. Okay. Moving on. We're now on to this. So we're going to correct that tomorrow at the beginning of class. We're going to move on to this. We'll correct this after Christmas. But polynomial functions, polynomial and linear functions, 6-3. It is a hoot. Yes, for sure.